Okay, here we've got a couple of objects on inclined planes. So we're going to assume that these objects are stationary and therefore the forces on them are in equilibrium. This is the force of weight, and this force here is the friction force acting up the slope, resisting the movement of this object, and therefore the object is not moving. Now, if we draw these forces up here, we've got the 30 Newton force there. Okay, so that's your 30 Newton force. And then we've got the weight acting downwards like this. Okay, so that's your 50 Newton force. Now, we know that these forces are in equilibrium. If they're in equilibrium, they must form a closed loop in order for them to be in equilibrium, okay? So there must be a third force acting there, and that's supposed to be at 90 degrees, but I haven't drawn it very well, sorry. So we know there must be this third force because that when you put the forces head to tail like this, they must form a closed loop if there's no resultant force. So this force here is the normal force, and it acts at 90 degrees to the surface. Okay, so that angle there is 90 degrees. So that's the normal force. Now we can work this out using Pythagoras. So 50 squared minus 30 squared, and then we square root that. That's going to give us 40 newtons. So this is 40 newtons, okay? We can then work out this angle here, theta, and that angle there is the same as this angle here, and I'll explain why in a moment. Let's just work out the angle first. Now this is the opposite, this is the hypotenuse, so therefore we can use sine theta. So theta is equal to sine to the -1 of the opposite over the hypotenuse, and that's going to give you 37 degrees, okay? Because we know that sine theta is equal to opposite over hypotenuse. So we just got opposite over hypotenuse, and we've brought the sine over this side and done inverse sine. Gives you 37 degrees. Now, how do we know that this angle here is this angle here? Well, it's because we know that this angle here, okay, and we can call that phi. We know that phi must be equal to, well, this angle here is 90 degrees. This angle and this angle must add up to 90 degrees because the total of the sum of the angles in a triangle must make 180 degrees. So if that's 90, this plus this must also be 90 to give you 180. So that angle there must be 90 take away theta, because we know that theta plus phi must equal 90. So if that's 90 minus theta, that's important because if we extend the normal line down like this, and that's supposed to be at 90 degrees to the surface, and then we draw the surface there, so that's the surface, or the 30 Newton force. This is the normal line coming down here, the line that is perpendicular to the surface. We know that this angle here is 90, and we know that that is phi. We know that the angle between the surface and this normal line is 90 in total, so that's 90 in total. If that's 90 in total, then this angle here must be 90 minus phi, which is theta. So that angle there must be theta, okay? Well, that angle there must be theta, okay? Because it's 90 degrees, take away phi, which must be theta. So if that angle there is theta, that's the angle between the normal line, or the normal force line, and the vertical. Well, this is the vertical, and this is the normal force, and that's the angle between them. So that angle there is the same as that angle there, and that angle there. Right, so we can do the same thing with this one down here. So we know there must be a third force acting. We know it must be the normal force acting here in order for these things to be in equilibrium. We can draw the normal force like that, okay, the 4 Newton force like that, and this time it looks a little bit more like it's at 90 degrees, so that's 4, that's N, 90 degrees, and this then is our 7 Newton force, so we'll extend that down there. This is theta, okay, so N in this case now is going to be 7 squared minus 4 squared, and we're going to root that. So if we put that into the calculator, 7 squared minus 4 squared, and then we can root that. That's going to give us 5.7, so we just round that to 6 newtons because we only know these to one significant figure. So that's going to be 6 newtons. And then the angle theta, remember this is the opposite, this is the hypotenuse. So sine theta equals opposite over hypotenuse. Therefore theta equals sine to the -1 of 4 over 7. So if we do 4 over 7 and then sine the -1 that, we're going to get 34.8. So that would round up to 35 degrees. Okay, this angle here is 35 degrees. And again, if you remember, the reason we know that is because we can extend the normal down like that, the normal force line down like that. We can draw the 4 Newton force line like that. That's 90 degrees there. So this is theta, that's 90 degrees. So this angle here must be 90 take away theta. So that angle there is 90 take away theta. The angle between the surface and this line here, that's 90 degrees between this normal line and the surface. So obviously between the surface and this normal line is 90 degrees in total here. But if that's 90 take away theta, this angle here must be theta. So that angle is theta, that's the angle between the vertical line and the normal. The angle between the vertical line and the normal is theta, and that is the same as this angle here. Okay, so there you go.